Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department from Praveen Patil College of Diploma Engineering and Technology. The name of the subject is EMI, that is Electronics, Measurement and Instrumentation, and we will start with the first unit, Fundamentals of Electronic Measurement. Now, what are the learning outcomes of this video? The learners will be able to understand what is a measurement, fundamentals of electronic measurement, instrument characteristics, in that static characteristic of an instrument. First, we will see what is measurement. The word measurement is used to tell us the length, the weight and the temperature or the change in one of these physical entities of a material. Now, why measurement is useful and important? That is the significance of a measurement. The measurement is useful and important for first, controlling some variable in process within its specified unit, to specify particular quantity, to monitor some variable in process, to study and analyze different elements of a machine structure, and for testing the quality of the product. Now, fundamentals of electronic measurement. This is the block diagram of a general electronic measurement system. In this, you can see first block is measurand, then transducer, signal conditioning, and then display or record. We will see the function of each block. First block is measurand. Measurand is nothing but your input. Whatever input you will apply to the electronic system, that is nothing but your measurand. The quantity to be measured is called as a measurand. Now, next block is transducer. Transducer is a device that converts a physical quantity into an electrical quantity or vice versa. Transducer converts one form of energy into the another form of energy. Normally, the output of the transducer is a electrical form because the electrical signal is easy to measure. Electrical signal like voltage, current, resistance, these signals are easy to measure. That's why most of the transducer gives the output in the electrical form. Now, third block is signal conditioning. Signal conditioning will only modify the output of the transducer. It will not convert one form of energy into another form of energy. Signal conditioning only modify the output which comes from the transducer. For modification purpose, it will use the circuit as amplification, filtering, modulation, demodulation, A to D conversion, etc. Now, why signal conditioning is important? Because sometimes the output of the transducer, it is not in the proper form to display. That's why signal conditioning will modify the output of the transducer into the proper format. If the strength of the output of the transducer is low, then it will use the amplification circuit to amplify the signal. If the noise is present, then it will use the filtering circuit to reduce the noise. If your display it is in digital form, then it will use the A to D conversion, that is analog to digital conversion. If the output of the transducer is in analog form and your display is in digital form, then signal conditioning have the circuitry of A to D conversion. Okay. Now last block is display or record. The quantity is recorded using recorders or display on the monitors, etc. Now any general measurement system as shown in figure will have a transducer that converts physical quantity into an electrical form so that the signal may be modified suitably according to the requirement. Signal conditioning devices will carry out this task and the parameter to be measured is display or recorded. Now we will see the instrument characteristic. The performance of an instrument depends on its characteristic. Suppose you can take any instrument like voltmeter. The performance of the voltmeter will depend on its characteristic. Now there are different characteristics of the instrument. Mainly they are divided into two parts. First is static characteristic, second is dynamic characteristic. Static characteristic is nothing but a fixed characteristic which is not vary with respective time, while dynamic characteristic are the variable characteristic which are changes with respective time. You can see here static characteristic: when the quantity under measurement do not vary with respective time, that characteristic is called as static characteristic, and when the quantity under measurement changes with respective time, that quantity is called as the dynamic characteristic. Now there are different static characteristic and dynamic characteristic according to which, depending on which the instrument performance is decided. Now we will first see the static characteristic. First characteristic is the accuracy. Accuracy is the degree of closeness with which an instrument reading approaches the true value of the quantity being measured. Degree of closeness with which the instrument reading approaches the true value. Now what is the true value? True value, that means the value comes from the standard instrument. There are some standard instrument and some measuring instrument. The output of the standard instrument is called as the true value and the output of the measuring instrument is called as the measured value. The measuring instrument always compared with the standard instrument. That means always compared with the true value. Accuracy is always calculated or measured in the percentage. You can say the 98% accuracy, 99% accuracy, 100% accuracy, like that. Now next characteristic is static error. Static error, you can define it is the difference between the measured value and the true value of the quantity is called as a static error. Measured value, that means the value comes from the measuring instrument, and the true value, the value comes from the standard instrument. The difference between these two is called as a static error. Now next characteristic is the precision. Precision is the degree of exactness for which the instrument is designed to perform. The precise precision is used in measurement to describe the consistency of a result. Now voltmeter, suppose voltmeter is standard value of the voltmeter is the 150 volt, and here 4 voltmeters are used: V1, V2, V3 and V4. Suppose we'll consider a V1 voltmeter. We will measure the voltage from the voltmeter, and it will show the reading 144, 144, 144, 144. 4 times we will measure the same reading and it will show the 144 value. So you can say that the instrument is precise, but it is not accurate. Why it is precise? Because 4 times it will show the exact same value. So you can say it is a precise instrument. But it is not accurate. Why it is not accurate? Because our standard value is 150 volt. Voltmeter V2 149.1, 150.1, 149.5, 149.6. You can say this instrument is accurate, but it is not precise. Not precise because it will 4 times it will show the different value. That's why it is not precise, but it is accurate because our standard value is 150 volt and it is very close to the, or the 4 values are very close to the 150 volt. So you can say this instrument is accurate, but it is not precise. Now consider the third voltmeter V3. V3 voltmeter shows the reading 145, 152, 148 and 155. So you can say that this instrument neither accurate nor precise. Because not precise, why it is not precise? Because it will not show the same reading. It will show the different reading 4 times. So it is not precise and it is not accurate because our standard value is the 150 volt and it will shows the reading far away from the 150 volt. Okay. Now last voltmeter, that is voltmeter V4. It is accurate as well as precise because all the 4 times it will show the value 150 volt, 150 volt, 150 volt and 150 volt. That means it is precise. Why? Because again and again it is showing the same value, that is 150 volt, and it is also accurate because our standard value is 150 volt and it is showing exactly same as the standard value. Okay. Now like this the precision is decided. Your instrument is precise or not, it is decided on the exactness of the instrument reading. How your instrument gives the exact same reading again and again, according to that the precision of the instrument is decided. Thank you.